So continuing my exploration of GraphicsMagick and its use in Cold Fusion or Lucee CFML, I wanted to see if I could extract a RGB hex color value from a given pixel within an image. So here's my color palette just to give us a nice variety of colors to choose from. And the idea is I'm going to click on this color palette and you'll see that I'm sending the XY coordinates of the given pixel to the server. Lucee CFML is then extracting that pixel value, and then we're using the color of that pixel to paint the background of our page here, right? So I can click around and you can see that as I'm clicking right down here, this is, oh, holy cow, I got pure blue there. Oh no, I guess 256 is pure blue. But you can see that as we click around, we're getting different hex values, different RGB values, and this is the duration of what it takes to read this value from the image using GraphicsMagick. Groovy. So let's take a look at how this works behind the scenes. So what I'm going to be doing is reading in the palette PNG, that's the image that I'm rendering here. I'm then going to be using the XY coordinates given by the URL, and I'm going to use that to read in a particular pixel. Now I'm going to use the convert utility, and this works essentially by cropping the image down to a 1:1 canvas at the given XY offset. So essentially, you know, if I click at 100, then I'm going to go to offset 100 and crop it to a 1:1 pixel, giving me the single pixel in the result of this that contains the pixel that I'm interested in. Then I'm going to ensure a 8-bit color depth, so we get a single byte per color channel. I think, I'm not 100% sure how colors work. Now here's the cool part, is that typically we would write the result of a GraphicsMagick operation to a file, but in this case we're going to use the dash notation to actually write it to the standard output, so that when I use the CFExecute tag to execute my GraphicsMagick command, my success result variable here is actually going to contain the result of the GraphicsMagick operation. Now we're going to take that feature and combine it with the fact that you can actually write to a TXT file format. Now when you write to a TXT file format, GraphicsMagick will actually iterate over the pixels, perform pixel enumeration, and write the RGB and hex and XY coordinates of each pixel to the given text file. Let's take a look at how that actually works, right? So let's come back and let's say change this to a 100x100 canvas, and let's go ahead and echo the results here. And let's just put it in a pre-tag because it's going to have line breaks in it, and let's write out the success result. And let's abort. So again, we're going to be reading in a 100x100. We're going to be reading in our image. We're going to be cropping it to a 100x100 canvas. We're going to be writing that canvas to the text format, which is going to perform the pixel enumeration. We're going to write that enumeration to the standard output, which is going to make it available to the CFExecute result. And then we're going to just dump that to the page. So let's take a look at how that works. And here we go. So this is the pixel enumeration of our 100x100 canvas. You can see we have our XY coordinates going across going across and then down. Each one has an RGB color and a hex value, and because this is quite an easy pattern to match, we can just use our regular expression patterns to parse out the first 6 digits characters of the hex. This actually has 8 because I believe this is an alpha channel. This also has the alpha channel here, but you can see there's no alpha values in this particular image. So going back to our 1:1, right? So we're getting this to a 1:1. We run this again. You can see that our output now only has a single pixel, right? It's at the 0, because we've cropped down to a 1:1 canvas and a single hex value. So then we can grab that single line of output, use our RE match and regular expression functionality to grab the first 6 digits of that hex, and then we're going to grab the first match because this returns an array, and you can see then we're using that to color the background of our body tag. And then as far as the RGB values, I'm just using the input base n to format the individual portions of that hexadecimal value into a decimal value. So we're reading in 2 pixels for red, 2 characters for red, 2 characters for green, 2 characters for blue, and then we're formatting it, or we're converting it from a 16 base to base 10 for our RGB. And then the JavaScript, again, is just capturing the click event on the image, translating the viewport coordinates into image local coordinates, and refreshing the page with the XY coordinates. And again, that's why we get, as we click around here, we can see that the pixel color drives the background color of the page. And yeah, it's pretty exciting. This runs super fast on an image this size. As the image increases in size, the duration increases, so there's clearly a relationship between the speed of this approach and the size of the image. We're still talking about sub-second time, but if you have a large image, then it takes longer. Anyway, this is just me getting more familiar with GraphicsMagick and how I can use it in ColdFusion CFML to replace some of my CF image functionality, which I've always felt has been a little bit janky. And yeah, if anybody has any suggestions on how to do this more efficiently with GraphicsMagick, I am all ears.